Okay, children, so in previous video we had stopped over here, so let us proceed now. Now exercise 12.1b part. Okay, so the first question is write down the sum and product of the roots, okay, of the following equations. Okay, so here quadratic equations are given to us and they want us to write the sum and the product of the roots for each quadratic equation. So the first one is 2x squared minus 3x minus 2 is equal to 0. Here a is 2, b is minus 3, c is minus 2. So you note that in the first lecture only we had discussed about these things. Okay, we had seen what will have the sum of the roots and what we are going to have the product of the roots. So if you have got a quadratic equations ax squared plus bx plus c is equal to 0, then sum will be minus b upon a, okay, and product will be c upon a. So here's sum of the roots minus b upon a. So substitute the values, you get the answer. Okay. So here minus 3 is the b and upon 2, a is the 2. Then you get here minus minus plus, so 3 by 2. C is your minus 2, okay, and a is 2, so you get minus 1. Okay. So same way do 2 and 3 by yourself. Now 4, firstly you got to simplify this, okay, and you have to get this into ax squared plus bx plus c is equal to 0 form. Okay, then you know how to find the sum of the roots and product of the roots. Sum of the root minus b upon a, product of the root c by a. Okay, next question number 2, number 1, for what value of m, the sum of the roots of the equation 2x squared minus 3mx plus 10 is equal to 0, okay, is 6. Okay, so you have got this quadratic equation 2x squared minus 3mx plus 10 is equal to 0. Okay, and they are asking you what should be the value of m. Okay, what should be the value of m so that the sum of the roots is equal to 6. Okay, so see the solution for the first one. So this is the quadratic equation. They are looking for the value of m for which the sum of the roots should become 6. So I know that sum of the roots is given by minus b upon a. Here my b is minus 3m. Yes, minus 3m is my b over here. So substitute the values. Okay, so I get 3m upon 2. But sum of the root should be how much? 6. In the question they are saying that sum should be 6. So in place of sum of the roots I am writing 6. Now simplify it and we get the value of m, and m comes 4. Yes. Question number 2, for what value of m the product of the roots of the equation, okay, for this equation, okay, the product should be 13. So what should be the value of m so that when I take the product of the roots, okay, so it comes 13. So question number 2, we have the quadratic equation, this, yes, and we know that product of roots is equal to c upon a, and my c is what? M plus 8. So m plus 8 upon a means 1, and we are looking for the value of m so that the product of the root should be how much? 13. So that means product of the root should be 13. So in place of product of roots I'm going to put 13 and then simplify it and you'll get the value of m. That means if in place of m I have got 5, okay, then product of the roots will be 13. Okay, and question number 3, given a quadratic equation, this is the quadratic equation given to us, we have to determine the value of p and q. So here p and q are there. Okay, so we have to determine the value of p and q so that the roots of the equation, okay, are p and q. Okay, so here this is the quadratic equation and we are looking for the values of p and q such that the roots also are p and q, so that the roots are also p and q. Okay, now see, so this is the quadratic equation given to us, yes, and further given p and q are roots. Yes, they are saying that these p and q are roots also. Okay, and we have to determine the value of p and q. Okay, so we have to determine the value of p and q such that p and q are the roots also. Okay, so firstly we know that sum of roots is equal to how much? Minus b upon a. So here what is the value of b? P. So minus p upon 1 I get. Okay, and sum of the roots. So you know that roots here are p and q only. So sum of the roots I can write p plus q. Yes, because roots are what? P and q. So sum of, in place of sum of roots I can write p plus q. And you know that sum of roots is given by what? Minus b upon a. So here b is what? P. So minus p upon 1. So I get q equal to minus 2p. Okay. And next we know that product of roots is given by c upon a. And here roots are what? P and q. So p into q. And what is the value of c? Q. So q upon 1. So you get p equal to 1. Yes. So you got p equal to 1. So what you do? Use this value in this equation. Okay. So that way you will get the value of q also. And that way you will get the value of q equal to minus 2. Okay. So when you're copying it, please try to understand it also. Okay. Don't copy it blindly. Okay. And things are very systematic. You just got to understand the question. Okay. And then whatever is given there, from there you just proceed on. Question number 4. If one root of the equation 3x squared plus 5x plus c is equal to 0. So this is the quadratic equation. And they are saying that one root of this equation is 2. So obviously that a quadratic equation has got two roots. Yes. But for this quadratic equation, they are saying that out of those two, one is this. Okay. And that one is this. Okay. So we have to find the other root. Done. So now we know the relations between the roots, like sum, okay, and the product. Okay. So we are going to use those relations only. Okay. So here what we are doing, we are assuming those roots to be alpha and beta. Okay. So, and I'm letting alpha to be 2 and beta I don't know, because out of two roots, one is given to us. Okay. So here I'm taking the roots to be alpha and beta, and one I'm assuming to be 2. Okay. So alpha is equal to 2 and beta I don't know, the other root. Now what happens? I know the relation between these roots. Okay. I know if I add them, what I will get, and if I take the product, what I'm going to get. Okay. So when I add those roots, I should sum should be, the sum of those roots should be minus b upon a. Okay. So here in place of alpha I can put 2, beta I don't know, so simply beta. B I know it's 5 and a I know it's 3. Okay. Now simplify it, you get the value of beta. Okay. So you got the other root. Yes. You could have used alpha into beta also, but that could not have helped you, because here this c is not a number. Okay. So then you would have had problem. Okay. So that's why better you use alpha plus beta, the sum. Okay. Because alpha into beta involves c upon a. So I know the a value, it's a numerical 3, but c, it's not a fixed value over here. Okay. That's why alpha plus beta was used in order to find the other root. Question number 3. If alpha and beta be the roots of this quadratic equation, find the value of these 4. Okay. So for this quadratic equation, alpha and beta are the roots. Okay. And we have to find the value of this. Okay. So see over here. Now what we know about the relation between the roots, we only know about their sum and we know about their product. Okay. Because you know that general equation of a quadratic equation is ax squared plus bx plus c is equal to 0. So using this a, b, c, okay, relation between these roots, okay, we know only two relation. Alpha plus beta is minus b upon a, and alpha into beta is c upon a. Okay. So we have to, in order to find these values, okay, we have to use alpha plus beta and alpha into beta. Okay. So let us see. So this is the quadratic equation, and they are saying that alpha and beta are the roots. Okay. So if alpha and beta are the roots, then sum of those roots should be minus b upon a. And b is what over here? Minus 4. Yes. And a is what? 2. Okay. So that way you get 2. When you put these values, calculate it, you will get 2. So sum of those roots should be 2. Okay. Next, product of those root, I know it's c upon a. Substitute the values and I'm getting half, minus half. Okay. So product is coming minus half. Okay. Now what we'll do is, we will use alpha plus beta, value of alpha plus beta and alpha into beta. Okay. For in each, okay, to find these values. Okay, but if you see the first one, it is 1 upon alpha plus 1 upon beta. This, what you have to do first, in order to use alpha plus beta and alpha into beta, I have to write this, okay, this expression in terms of alpha plus beta and alpha into beta. Okay, so let us see. So number one, 1 upon alpha plus 1 upon beta. Now I can take the LCM, okay, or you can say cross multiply. So you get, when you do the cross multiply, you get beta plus alpha, and down you get alpha into beta. You don't know the value of alpha, you don't know value of beta, but you know alpha plus beta and you know alpha into beta. Yes, that's why this expression was first, you have to try to write in this form. Okay, you got to express this in terms of alpha plus beta and alpha into beta, to use the values of alpha plus beta equal to 2 and alpha into beta equal to minus half. So I have expressed it. Now simply substitute the values and you get the answer. So 1 upon alpha plus 1 upon beta is nothing but minus 4. Next, you have to find the value of alpha square plus beta square. I don't know alpha square plus beta square, but I know alpha plus beta and I know alpha into beta. So you have to write in terms of alpha plus beta and alpha into beta. So what we can do is, here alpha square plus beta square, to that I'm adding 2 alpha beta, and again I'm subtracting 2 alpha beta. So this way the second step is, okay, the value of the second step is also same as this one. Okay, there's nothing changed. Okay, because you're adding and once you're subtracting also. But if you see, if you only see the first 3 terms, okay, this can be written as alpha plus beta whole square. Yes, minus 2 alpha beta. Now you know the value of alpha plus beta, you know the value of alpha into beta. Substitute those values and you get the answer. You get 5 for that. Okay, here it is alpha minus beta whole square. I know the value of alpha plus beta, I know the value of alpha into beta. Okay, if I am given a quadratic equation, then I can tell what would be the sum of the roots and what is going to be the product of the root. Okay, I cannot say what will have their difference. Okay, so here alpha minus beta whole square we have to find. So what we'll do, first we are going to try to write this in terms of alpha plus beta and alpha into beta. So first expand this. So using a minus b whole square formula, expand it. So by expansion you get alpha square plus beta square minus 2 alpha beta. Okay, now what I'll do, I want to write this in alpha plus beta. So alpha square plus beta square, if I had plus 2 alpha beta, then I could have written it alpha plus beta whole square. So that's why I'm adding it. Okay, adding 2 alpha plus beta, 2 alpha beta, and I'll subtract 2 alpha beta. So that way I'll get plus 2 alpha beta and minus 4 alpha beta. So it still is same. Okay, but first 3 terms, okay, for first 3 terms you can write this alpha plus beta whole square minus 4 alpha beta. Now you know the values. Okay, substitute the values, you'll get the answer. Number 4, alpha square upon beta plus alpha square upon alpha. Okay, so here you got to simplify again. Okay, you have to write in terms of alpha plus beta and alpha into beta. Okay, so you have to express this. Okay, this expression such a way that that expression includes alpha plus beta and alpha into beta. So what I'll do, cross multiplication. So I get alpha cube plus beta cube, and down in denominator I get alpha into beta. Okay, now this alpha cube plus beta cube can be written as alpha plus beta in bracket alpha square minus alpha beta plus beta square, and denominator I've got alpha into beta. The numerator alpha cube plus beta cube I have expanded in this form because of this formula. Okay, you have to remember this. Now for alpha plus beta simple, I know the value. For the denominator alpha into beta, I know the value. But what about this? Alpha square minus alpha beta plus beta square. So what I will do is, I will try to write this in alpha plus beta whole square form. So in order to write this alpha plus beta whole square, that plus 2 alpha beta is missing. So I'm introducing, okay, plus 2 alpha beta. Okay, so if I'm introducing, then I have to subtract also. So when I'm subtracting, this will become minus 3 alpha beta. Okay, in next step I'll get alpha plus beta in bracket alpha plus beta whole square minus 3 alpha beta and whole divided by alpha beta. Now you see that you had started with this. Okay, and now you have been able to write it in this, okay, where you can see you have got alpha plus beta and alpha into beta. Okay, so you have been able to express it in this form. Okay, now you put those values, okay, and you get the answer. Done. Okay, so this is a question, this question had come in 2019. Okay, so here this says that given that alpha and beta are the roots of the quadratic equation px squared plus qx plus 1 is equal to 0, find the value of alpha cube beta into beta squared plus alpha squared into beta cube. So this is the quadratic equation given to you. They are saying that alpha and beta are the roots of this, and you have to find the values of this. Okay, so what you can do is, first you will find the values of the sum of the roots and the product of the roots. So alpha plus beta is minus b upon a. So here b is what? Q. So that's why minus q upon a. A means p over here. Alpha into beta is what? C upon a. That means 1 upon p. Okay, c upon a. So 1 and here p. So 1 upon p. Now we are looking for the value of this a cube into b square plus a alpha square, alpha cube into beta square plus alpha square into beta cube. So we are looking for this. So you have to write this in terms of alpha plus beta and alpha into beta. Okay, so here you can see that from each term alpha square is common and beta square is common, so we take them out. Okay, so alpha square into beta square, and then you are left with alpha plus beta. Okay, now this can be written as this. Now clearly we have alpha beta, you know the value, alpha plus beta, you know the value. Put the values, you get the answer. Answer is minus q upon p cube. Okay, and next is find the equation whose roots are this. Okay, so we had discussed how to find the quadratic equations once you know the roots. Okay, and the formula was you have to write x square minus sum of the roots x into x plus product of the roots equal to 0. So in this question, question number 4, roots are given and we have to find the equation. Okay, so let us do the first one. Given roots are this. So here I'm taking this to be alpha, other to be beta. So it depends on you. You can take any one alpha, you can take the other one beta. Okay, so I've taken alpha to be this, beta to be this. Now the quadratic equation whose roots are alpha and beta is, okay, so if you know that the roots are alpha and beta, then this is how we write the quadratic equation. So if we have got the roots alpha and beta, then the quadratic equation is x square minus in bracket alpha plus beta into x plus alpha into beta is equal to 0. Now substitute the values, okay, alpha's values, beta's values, okay, and then you simplify it, and at the end you will get an equation of the form ax square plus bx minus plus c is equal to 0. Okay, so this is the required quadratic equation whose roots are 3 by 4 and minus 2 by 5. Number 2 is left as homework for you, and number 3 I've done over here. Given roots are these. Okay, so the quadratic equation whose roots are given, okay, is given by this. Yes, you could have done the same way. You could have taken this to be alpha and beta. Okay, you could have done that way also. So I'm not assumed this to be alpha beta, straight I'm writing. Okay, so x square minus sum of the roots. So here I have to add this 2 and then I have to write into x plus product of the roots multiply right over here. So substitute these values. Okay, and after that simplify it and you get an equation, quadratic equation over here. Yes. Next, question number 5. If one root of this quadratic equation of, if one root of this ax square plus bx plus c equal to 0 be twice the other, prove that 2b square is equal to 9ac. So here they are saying that this is a quadratic equation, and they are saying that if one root is twice the other. Suppose one root is 2, then other root is 4. Okay, if one root is alpha, then other root will be 2 alpha. So they are saying that suppose for this quadratic equation one root is the twice the other, then you have to show that 2b square is equal to 9ac. So let one of the roots be alpha. Okay, then according to the question other root will be 2 alpha, twice of the one. So one I am assumed alpha, then other is 2 alpha. Now I know the relation between the roots in terms of sum and in terms of product. So when I take sum alpha plus 2 alpha, I get minus b upon a. Yes, so that means 3 alpha is equal to minus b upon a. Yes, so value of alpha is minus b upon 3a. Done. Leave this as equation start. And product of the roots means alpha into 2 alpha is equal to c by a. So it will be 2 alpha square equal to c upon a. Okay, from equation start put the value of alpha. Okay, and then simplify it. Okay, and you will get that 2b square is equal to 9ac. Okay, so this is proved. Okay, question number 6, homework you have done in class 10. Here you got to examine the nature of the roots. In the first lecture also, okay, in the first video also we had seen this graphically also. Okay, so for this you have to find the discriminant and accordingly you have to tell the nature of this. Okay, so you may do this. Question number 7. A. If alpha and beta be the two roots of this quadratic equation 2x square plus 3x plus 2 equal to 0, form an equation whose roots are this. Okay, so this type of questions are important. So here one quadratic equation is given to us. Yes, and then they are saying that alpha and beta are the roots of this. Yes, we don't know exactly what is alpha, what is beta. In fact here you can find, but there's no need to find. Okay, alpha and beta. Okay, we will use the relation sum and the product. Okay, so here this is the quadratic equation, alpha and beta are the roots of this, and what we have to do is we have to find equation of equation for which roots are this and this. Okay, so this is separate question, this is separate question. So here solution, alpha and beta are the roots of this quadratic equation. So we know sum of the roots will be minus 3 by 2 and product will be here 1. Alpha plus beta means minus b upon a. So here b is what? Plus 3. A is what? 2. So minus 3 upon 2. Alpha into beta is c upon a. That means 2 upon 2. That's 1. Yes. So I got this. Alpha plus beta this and alpha into beta. So we will be using this one in order to get the equation for this. Now we are looking for the equation whose roots are this. We are looking for the equation whose roots are this. And you know that if roots are given to you, then quadratic equation is x square minus sum of the roots, okay, into x plus product of the roots. So we are looking for the equation whose roots are alpha plus beta and beta plus alpha. So the equation will be x square minus alpha plus 1 plus beta plus 1 into x plus alpha plus 1 into beta plus 1. Okay, now what we'll do is we have to write this, okay, this in terms of alpha plus beta and alpha into beta. Same goes for this. Okay, you have to simplify and try to write this in terms of alpha plus beta and alpha into beta. Why? Because we are going to use this value minus 3 upon 2 and 1. Okay, so this when you simplify you get alpha plus beta plus 2. So simply you can use alpha plus beta value. Okay, this value can be used over here. Yes, and here when you simplify you get alpha into beta plus alpha plus beta plus 1. So here also simply you are getting it. Yes, so in next step substitute those values, okay, and simplify it and you get the equation. Okay, next And next we have to find the equation for equation whose roots are alpha upon beta and beta upon alpha. So roots are given to us, then equation will be given by this x square minus sum of the roots into x plus product of the roots. Now you got to write those this expression in terms of alpha plus beta and alpha into beta, and same goes for this. Okay, so simplify it. Okay, so here very easy for this, alpha alpha cancel, beta beta cancel, so you get 1. But here you have to simplify and try to write in terms of alpha plus beta and alpha into beta. So you know that alpha square plus this. So for denominator you don't have to do anything. Okay, for numerator you can add 2 plus 2 alpha beta minus 2 alpha beta. So you can get alpha plus beta whole square minus 2 alpha beta. Now you can substitute the values of alpha plus beta, alpha into beta, simplify it, and at the end you get the equation. Okay, and okay, so let us stop over here. Okay, so this is all for today.